Hey everybody, today we're going to work with the Pythagorean theorem in right triangles and similarity. So even though it says we're going to prove it, it's more about we're going to be using those right triangles and the ratios that we can get from similarity from them. Here for your vocabulary, let's make sure you copy this picture and of course write down your Pythagorean theorem. That's a squared plus b squared equals c squared. And we're not using that exactly, but we're using, again, the parts of it from the right triangles. The one thing you're going to want to do if you're not familiar with it is talk about this word altitude, which is another word for the height of the triangle. And I cannot pick my screen up and turn it around, but you could turn your paper around so that AB is the bottom of your triangle, like the base. And then from there, see if you can't draw straight up, which would represent the height. Straight up from the base to touch C, which would be the height. Should hit somewhere right about in there. And of course, if you draw straight up, that puts it at a right angle. That is your altitude. Perpendicular means you form a right angle. The one thing you're going to need to be able to do today is have that altitude drawn in on a right triangle and see the three triangles that are there. The original triangle ABC is the largest, and then there's what I call a small and a medium and a large triangle. So the small triangle would be this one on this side. The medium triangle would be this one on this side. I would call it a name, but I haven't put in a point there at the height. And then the large triangle, which is the original triangle ABC. The reason you're going to want to draw out three different triangles every time is because we're going to match up the similar parts, and that's where we'll get our similarity, our proportions from. Now, the other thing you'll want to do on each triangle, and I'm just going to draw the large one, triangle ACB there, is you'll want to make sure you do note the three side lengths of the right triangle. The hypotenuse is always the longest side. We'll also be referring to the short leg, which is the shortest of A or B, of the two sides coming out of the right angle. And then, obviously, the longer one of those two we'll call the long leg. So you'll need to be calling things the short, the long, and the hypotenuse today. Okay, so here we go. If you'll notice, the picture for example 1 and 2 is the exact same picture. We're just trying to give you more space to work with. So feel free to use all that space to write in. Our first job will always be to draw out your small, your medium, and your large triangles. And it's nice if you turn them all the same way so that you can match up short, long, and hypotenuse really easily. So I'm going to start with the small triangle. That's the one here on the right-hand side. It's the smallest of the three. That's triangle CBD with a right angle at D. And on that, this would be the short leg, this will be the long leg, and this will be the hypotenuse. And let's put any numbers or variables that we have. So we have an X on the long leg and a 10 on the short leg. All right, let's draw the medium triangle. That would be the one on this left-hand side. Now, I could draw it just like it is, but better yet, if I'll tilt it up, rotate it a quarter turn to the right, then I'll have it turn the same way as I have drawn the small triangle. So turn your paper if you need to and then come back. That would put A up here, C right here, and a right angle at D. Now I know I'm not drawing it larger than the small one, but the idea is that we turn them all the same way. So now let's put letters and numbers on there. The variable X, a side length AD of 18, and let's also label short, long, and hypotenuse. If you need to, always start with hypotenuse and get that out of the way. Here's short. Here's long. All right, let's go to the largest triangle, which is the original triangle, but I need to kind of turn it if I want it to match up like these others in my drawing. So maybe get it drawn first. This time the right angle is at C, and let's see, short leg runs from C to B, and A is up at the top. So here is short, long, and hypotenuse, and let's see what kind of numbers we have on there. The long leg, the hypotenuse AB is 18 plus 10, so that would be 28 units. And that is all we have on that one. Now, that leads us to how we're going to choose to set up our proportions. We've got to find something similar, so we're looking for any matching parts between any two of these three triangles. And just based on what I just said, that all I have on the large triangle is the hypotenuse of 28, more than likely, we're not going to use that one for our similarity ratio. So let's go back to and compare the small and the medium, and let's see if we have any matching parts. And it turns out we do. We have short leg and long leg in both of them. So we have short to long. And so I'm going to write those numbers in for the small triangle. Short to long would be 10 to x. Write those numbers in for the medium triangle. Short to long would be x to 18. So that's what you're looking for. I chose this because it was the one case out of the three pictures that I had where I had matching parts, even though one's a variable. So we're going to quickly solve that. You may go, wait a minute, we haven't done one like that with x times x. That's okay. Once you write it, I think you'll catch on really quickly that you can do the math. So you want to square root both sides. X will be approximately, because we're estimating here, the square root of 180, which is 13.4 units. We have found the length of the altitude x of that triangle. Some of our good geometry humor here. We have lots more, don't worry. All right, so here's example 3. It's also the picture for example 4. So again, use all of your space that you need because we do have several things to find this time. Again, first job, draw out the small, medium, and large triangles. I'm going to draw mine. You might want to try yours or just go ahead and look at mine and then pause it and get them drawn. Okay, so here are my three triangles already drawn out, and I've labeled them. Small, CDB, medium is ADC, and large triangle is triangle ACB. Now, our only job from this point on, we've got to find E, F, and C. Go to any two of the three triangles where you have matching parts that you can set up together in a proportion. So you want to look for anything where at the most you've only got one missing number. So the first one I'm going to go for is the small to medium triangles. And that's because I can match up. I have, for instance, the long leg and the hypotenuse in both of those, and numbers in all of those spots except for the E. So I'm going to go long leg to hypotenuse. So for my small triangle, long to hypotenuse is 4.8 to 6. For my medium triangle, the long and the hypotenuse is E and 8. Now you can do your cross products and find the value of E. I believe it's 6E equals 38.4. That makes E turn out to be 6.4. All right, so we have found E. Now we still need to find F and C. My guess is probably let's try to go for F next, since C is a combination of E plus F. So I'm going to go to my next slide, which is my example 4 spot, and let's set up another proportion. This time I'm going to do the small to large triangle and at least see what kind of matching parts we have. I think I can do short to long. Now again, it's your job to just sit and look and figure out, and you can set up any proportions, and as long as you only have one variable, you can solve it. If you happen to have two, you'll have to go, nope, can't do that one yet. So let's do short to long. That would be F to 4.8. That's coming off the small triangle. And then short to long for the large one would be 6 to 8. So once again, the deal is, as long as you can set up a proportion, you only have one missing number, in this case F, then you're good to go. 8F equals 28.8. You can solve for F. That'll be 3.6. Now, again, look back. You could probably do another proportion to find C, and you're welcome to do that. But in my case, I think I'm just going to go, oh, let's look at the picture. C is that whole length of E plus F. So if I'll add 6.4 plus 3.6, we'll have that C is 10 units. Okay, so that's it, and that's easy to say, I know. It does take lots of practice to get good at spotting your proportions that you want to write. We just did finding sides of right triangles by creating ratios. There is another method, I should say, and it's called the geometric mean method. Please see one of your teachers or Google that if you'd like to see that approach. Some people think that is easier. It doesn't involve the drawing, but it takes some thinking to figure out where it all comes from. So again, you want to practice, 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 and then this becomes pretty easy. That's all for today. Thanks.